Hello to everyone. Now we'll discuss in this class about the linear algebra in the machine learning subject. So to work with the machine learning or to train the different type of models in machine learning, we need the support of mathematical support when you are writing the linear equations, and we are using the different type of grammatical or some values we are using, some directions we are taking. So these are all the related to mathematics. So the when we are developing the machine learning models uh, and deep learning models, this mathematical support is 100% required. So in this class we will discuss about what is the essence of mathematical uh, uh, math with uh, ML. So the linear algebra concept is there. The linear algebra, it is going to giving insights uh, how the different type of what are the different type of ways are there to represent our data. So the data, as we already know that the machine learning, it is nothing but it is learning from the past experience, and it is going to be uh, training. We are going to building the machines uh, by using some algorithms. So in that algorithms, or while developing the models, what type of some of the mathematical support is required. So for that, what are the different ways of uh, ways are there in the linear algebra to represent the data? Let us see now. So first of all, scalar is there. Scalar, as we already know that a scalar is nothing but it is only the magnitude and no direction. It is only the value. So it is nothing but so in the machine learning models, different stages are there: training, testing, optimization. So on the, in all the stages, we may use some type of parameters, or the predicted value and the targeted value. The difference between the predicted and targeted value will be of scalar type. At the same time, learning rate acceleration will be useful. We are using in the learning rate. That learning rate also, it is of a scalar type. At the same time, uh, evaluation measures like F1 score and precision recall, these are some values. Finally the some scores will be evaluated. So again, these are also scalar values. So I hope you understand the scalar is nothing but in this machine learning, how we are going to using the machine learning, the values. So the single values or numerical values are considered as scalar values, right? Next, so let us take discuss about a vector. So vector by name itself, we already know that it has magnitude and direction. We already know that the vector, it is a collection of some numbers or scalars, as we already represented here. The vector, it is consisting of e1, e2, e3. So the values or the elements are there in this vector, or like it elements. V of 2 is e3 is nothing but, so the vector, this is, it has some direction and magnitude. So for the same vector, we will perform the magnitude also. So we'll see how the magnitude will be calculated, and what operations can be done on the vector. We shall see in the coming videos. So generally we have a row vector. It is of type, so this is row vector, and this is column vector. So this column, these vectors are also useful in our journey, machine learning journey or deep learning journey. The weight vector is there, and these are some of the special kind of vectors are there. Types of vectors, these types are encounter in this concept. Um Throughout the training process, this vector also will be acting as a weights also will be acting as vectors. So anyhow, we'll see the operations and types of the vectors in the separate video. So I hope you understand so what is vector and how the data is representing in the vector. Next, matrix. The matrix is a two-dimensional array of numbers. It is also one way of representing the data. In the machine learning, definitely the values or samples we are going to keeping inside the matrix. So the values will be adjusted in terms of matrix for easy calculation, and based on that the formula or equations will be there. So because of the machine learning mechanism or the deep learning mechanism, so we are building some model. The model should be accurate, and the model will be tested, and that model should be um, open to all. So whatever data we have supplied, it is going to be detecting the true or false, or detected or not detected, target or the actual. So when you are doing this, the supply of the data or representation of the data in some particular mathematical equation is required to understand by the others. So that's why these are the different type of representations are there. So out of them, the matrix is also one, and tensor. Tensor is so it is a series of scalars or vectors and matrices. So we can observe here, this is the complete tensor. It is of multi-dimension, 6 rows, 4 columns, and it is two here. This is the third dimension, 3D. Uh, so at the same time, it is of 2D type, and it is a 0 dimension. Uh, Vector is a 1 dimension, and if it is scalar, so we can see in this diagram clearly. So this is a 0 dimensional vector or scalar, and this is a 1 dimensional tensor, and this is a two-dimensional sensor, and this is a multi-dimensional sensor. So it is also type of multi-dimensional arrays also, we can call it as multi-dimensional array also. So these tensors are useful in our journey machine learning, at the same time especially in the deep learning. So in the deep learning, we are going to working with the neural networks. So in that neural networks, will represent the data in terms of tensor. Multi-dimensional possibility is there, because exclusively and especially so the data will be represented, image data will be represented. In that image, generally we have two categories: grayscale image and the color image. So when you are representing the grayscale image, it will be represented like a 2D sensor. So when you are writing 2D sensor, it's based on the pixel intensity. If the pixel intensity is grayscale, then it will be when you are supplying the code to the machine. So we have to give the one as for grayscale image. In the case of color image, 3D tensor, it is of color type RGB, red, green, blue channels. 3 channels we are supplying. So when you are writing the code and supplying to the machine, so we are giving three, including kernel size, image size, and the type of image. So if you want to see an example, anyhow, this will be discussed in the future videos, the convolutional neural networks. But however, just to see how the input will be supplied. For example, this is a kernel size or filters. These are the 32 filters are there, and so if you want to supply the image size of 64 by 64, and it is of grayscale type, then we have to give like this. Or else, in the case of RGB or 3D tensor, we have to give the number of filters. At the same time, the image size 128 by 128. So and we have to give the RGB mode, then it is of type 3. So however, this representation will be useful in the deep learning exclusively. So um, uh, so these are the different ways of representation. Mathematical representation is going to be useful in the machine learning as well the deep learning as part of the linear algebra concept. So that's all. We'll meet in the next video. Thank you.